Now let us take a look at the deletion. Deletion is the same thing with the insert. There are two cases. The first case is delete an element that has a predecessor, indicating that we want to delete something inside of the linked list. The special case is that you want to delete the very first item. So it's the same situation with the insert operation. Deletion. Let's take a look at the example. Saying that if we want to do a deletion, at this time, we just need one parameter instead of two parameters in the insert operation. Because for insert, you need to talk about what's the element value that you want to insert at which position. For delete, you only need to specify the location that you want to do the delete. So in the example that we see over here right now, this linked list has 5 items. Saying that I want to do delete 2, that indicating you want to delete the item after the second element, which means that in this case, the first element is 9, the second element is 17, and you want to delete the element after the second element. So 22 is the items that we want to do the deletion. Therefore, if you say delete 0, indicating the special occasion that you want to delete the very first item. If you say delete 1, that means you want to delete the element after the first item, which is 17. Again, in this case, we want to do deletion 2, indicating we want to delete the element of 22. So how do we do that? Saying that we want to delete the item of 22, this is the target item that we want to do the deletion. We need to have a pointer point at this item. And then we need to also specify what is the items before the item you want to do the delete. Because think about this. If you take away the node of 22, then we still need to have a linked list. This linked list will go from 9, 17, and then bypass the item we want to delete, which is 22 in this example, point at the item of 26. And therefore, we need to find out what is the item that's before the item we want to delete, just like the insertion. So once we have the top or the first pointer indicating where's the beginning, that's where we can search for the pre-PTR, and the next item is going to be the PTR item, and we will be able to bypass that and then forming the link through the following steps. First of all, we need to say at this time you need to have a very clear linked list idea. What we will do to form this red line, that would be pre-PTR next, which is here, will equals to this address. But the question is, what is this address? This address is PTR's next. So you can see this red line, to write the code for this red line will be pre-PTR next equals to PTR's next. And once we form this red line, we will be able to create the linkage. The item over there is no longer accessible because now once we create this link, we will have no way to link to the item of 22 anymore. So what we will need to do is that we need to remember to free the space, which is what we call a garbage collection. Free the space so that when operating system requires some random locations, if that choose that location, we will need to specify it is available over there. That's the idea of the deletion. And let's take a look at this. Here is the code for it. As I mentioned, when we do the delete operation, we require only one parameter, which is where we want to do the deletion. We create a pre-PTR equals to the beginning of the location. So now, not only we have the top, since we don't want to move it at all, we use pre-PTR to move for us. The same operation, the same loop that we will go through the positions until position -1, indicating where the pre-PTR location is going to be. Until we do that, we will just keep moving, make pre-PTR equals to pre-PTR next. So we will be able to move to the next location until we find the pre-PTR location. Then what we need to do is use that pre-PTR location, create a PTR equals to pre-PTR next, which gives you the idea of the pre-PTR and PTR. So we will have these two pointers available. And then what we need to do is form that red line, which makes pre-PTR next equals to PTR next over here. And don't forget to do the garbage collection, free the space. And therefore, this is the whole process of what we call the remove operation. So if we try to take a look of this example, try to understand it, saying that this is the linked list that we have right now. There are 6 elements in the linked list. In the example of the memory address that we are looking at right now, say top equals to 4, so we know that this is where we begins. It goes to the next item, which is A, goes and the value is 9. Go to the next item at location of 2, which is 17. So you can see 30, 9, 17. Goes to the next location 22, next location 6, and then next location 0, and then that's the end of it. So you can see that this linked list is a representation of what we have over here. Saying that we want to do remove 4. What that's trying to say is that I want to remove the item after the 4th position, which means that 1, 2, 3, 4, the element after the 4th location is the one that we want to do the remove. So we want to remove 26 away. So you can see that we will eventually take this away and then form the proper link goes to the end of it. So the same thing, I prepare the code on the left side over here, and we want to see what is happening over here. So in the beginning, what we need to do is that we see the remove 4 over here. So we have the position equals to 4. What we try to do is starting creating a pre-PTR, and then pre-PTR equals to top. So now what we're going to see over here is that we have pre-PTR equals to top over here, and then that's where we can start. So once we have the pre-PTR pointer equals to top, that's ready for us to go into the loop. So now the loop over here will starting from I equal to 0 until I less than position minus 1. Position is 4, position minus 1 is 3, so it will move from I to 2 over here. So that will give us the right location for the pre-PTR. So now let's take a look of what's happening inside the loop. So I equal to 0, we make pre-PTR equals to pre-PTR next. So you can see that pre-PTR equals to pre-PTR's next. So originally, you can see that originally pre-PTR is over here. Now we make pre-PTR equals to pre-PTR next, which goes to the A location. So you can see that the pre-PTR will move to A address right now. Next, I will increment by 1, so it will goes to 1, and then pre-PTR will equal to pre-PTR next. So the next location is at 2, so you will move to the next location. So you see that we have moving from here to now we are looking at the items of 17. So if we do one more time, I will increment by 1 goes to 2, so it will goes to the address of 7, which is where 22 located at. So you can see that it will move to this location. So pre-PTR is at address of 7. In this case. Now, we will increment I by 1, but we will need to stop the loop because it's already stopped the loop. Basically, I is not less than position minus 1 anymore. So we find out the pre-PTR address, which is at the address of 7, and that's where it stores the item of 22. Now, so we have finished the loop over here. We will go into the 3rd line of the code, which forms the most important deletion operation. That's going to be, we create a PTR equals to pre-PTR next. So we create a PTR, and then that will equals to pre-PTR next. So you can see that pre-PTR next over here is 6. And that's what we are going to do is that we're going to make that equals to PTR. So now PTR is at the address of 6. So you can see that we have pointers, point at this element, point at this element. This is where we want to do the deletion. So we will move into the most important part of the code, which is this one, pre-PTR next. So you can see in the next slide, what you can see is that we make pre-PTR next, which is this location, will equals to PTR next. So we put this 0 over here because that is where the next item is supposed to be. Now we have put this address in here, and we will be able to see that after this one, we will go into the last item in this example. So we will be able to have that information with forming the pre-PTR next equals to PTR next. So finally, we need to remember to free the space. So we do delete PTR, then we will free the space, and that will indicating this space is now available. That is the process of the remove or the delete function in the linked list. Therefore, you can see that in the delete operation, to see the whole process, the one that we have went through is the general case scenario. So you can see that this is what's happening of the code that I post on the left side, or the one that we have just discussed. On the other end, we have a special case saying that if we want to delete the very first item, what is going on? And you can see it's actually an easier situation. So what we are going to do over here is that we create a PTR equals to top. Think about this, because we want to delete the very first item. So if we use PTR indicating the one that we want to delete, it is exactly the top. In this case, there is no pre-PTR. And what we are going to see is that we're going to make top equals to pre-PTR next. So we will bypass the current top item, go to the next address, and then we just free the space. And therefore, you can see that in this case, when we try to remove 0 from the current linked list, is that we will take away this item. And what's happening over here is that we're going to do PTR equals to top. So we create a pointer, PTR equals to top. So they are point at the same address right now. Since the PTR is the item we want to delete, we want to make sure top will go into the right location, which is the second item at the linked list right now. So the top, you can see that the top is equals to PTR next. So originally, you can see the top is in here. Now we want to make it equals to PTR next, which is the address of A. So your top will go to this, the next address over here, which is the place that stored the value of 9. And all we need to do next is free the space. And then we will be able to do the perfect deletions about the special case scenario, which is deleting the very first item. In this case, you can see that we have basically go through all the informations that we have seen. So the advantage of the linked list is that we will be able to access any item as long as the external link to the first item is maintained. So we can insert, delete items without doing any shifting, unlike arrays. So this is going to be a very useful structure to do the operations. It can expand and construct as necessary. I also found this link, the website over here, talking about the linked list, a very useful resource. So I have included that in my slide. If you are interested, you can take a look of that. Not only it has a very good descriptions about all the process, insert, delete operation about linked list. Something special over here is that they provide all different kind of languages to implement linked list. So the one that we focus in UCA program, computer science program, is C++. But this website also talk about how to do linked list in Java, how to do linked list even in Python. So I think it's a useful resource for you to take a look. However, there are some disadvantages. Since the address, you can see that the address of all the items are jumping around. We are no longer be able to use array index anymore, because you have to travel from the beginning, search for the next item, search for the next item. So to access the nth item is now less efficient. You cannot jump to the middle. Unlike when we are doing the binary search, we can look at the middle item and then look into the left side or the right side. In linked list, we cannot do that anymore. We have to travel one by one. That is the major disadvantage compared with the array. So there are always a comparison, or there is always a catch of which one that you want to use. Some advantages are good for the problems, but probably not for the other one. So you need to understand what are the advantages and disadvantages of doing the linked list. After this video, I will introduce you guys the lab opportunity as well as the project assignment for you to work with, so that you can make sure you understand the whole concepts about the linked list completely.